So good morning, everyone, and welcome back once again. We are now beginning the course on end-of-life bioethics, bioethical issues at the end of human life, within the program of the Master of Science in Bioethics at St. Thomas University. Beginning always with a little prayer. In the name of the Father, the Son, and the Holy Spirit. Come, Holy Spirit, fill the hearts of your faithful and kindle in us the fire of your divine love. Through Christ our Lord. Amen. Okay, I hope you had a good spring break, little break. So busy.
I had a bad allergy.
Oh, you did? Oh, yes, the spring pollen. Oh, I'm sorry. Yes. So.
I've been quarantined.
Oh, yes.
A lot.
The mango. Oh, really? It just flare out. Amazing. Yes, a lot of pollen right now. Oh, I'm sorry. So you have to take histaminics. Also. Mm-hmm. Wow. Yes. Sometimes they make you sleepy. Mm-hmm. Yes. Okay. I guess you adjust a little bit. The immune system is something so incredible. Huh? Sometimes we become sensitized. Sometimes we become desensitized. My sister-in-law is the same. She's from up north originally, and down here, every spring she flares out with the allergies, unfortunately. Yeah. I had an event also last Saturday. At dawn, I started getting this toothache, a molar on the upper left, and it became so painful that just to touch it with my tongue would give me a lot of pain. Couldn't believe it. So try to find a doctor, a dentist on a Saturday morning, right? Thanks be to God, I did find one over by Miami Lakes. And he took a look, and yes, it was an abscess in one of the molars on the inside, becomes inflamed, and then it builds pressure and pushes the molar out. So along the short, I ended up having a root canal over the spring break in 2 sessions. He started that same Saturday morning, and he finished it yesterday morning. But it's amazing. I had relatively little pain. And here I am 24 hours later talking and eating. So he's a good dentist. Anyway, that was the event of the week. I did manage to have some free time in between though with my brother and sister-in-law. Anyway, we're back now. We're making the transition from the beginning of life bioethics to the end of life. So we're going from one end of human life to the other extreme. And one of the first things to notice here is that whereas at the beginning of life, whether it's human or non-human, for any species, we always begin with a single cell, which for those animals and plants that reproduce sexually, that is a zygote, right? And for those that reproduce asexually, it will be essentially a clone, but still a new cell. Well, there at the beginning of life, we begin with a single cell that, as you know, now is totipotent and so forth, capable with the capacity of developing the entire new individual. At the end of life, we have literally trillions of cells, right? And guess what? They don't all die at the same time. In fact, they're not gonna die at the same time for sure, okay? And so from that perspective, from the biological dynamics of dying, the dying process, it is more complicated than the beginning of life, because we can say for sure within a 24-hour frame, at least for the human and most mammals and many other species also, when we are talking about fertilization, within 24 hours from initial contact of the egg and sperm to syngamy, which is the fusion of both haploid nucleus, both pronuclei, to restore the diploid number, right? That's 24 hours, and within those 24 hours, we have that new individual in the single cell of the zygote. At the end of life, these trillions of cells are dying at different times, which may take hours, days, weeks, or maybe even months to fully die all of the cells within an organism, in particular the human as we see and as we will see. So rather than focusing on individual cells, we have to focus at a higher level, a higher order of organization, basically at the level of organs. And so we're going to look at vital organs, okay? And this first lecture will be devoted, at least the first part, mostly to a review of the vital organs. However, before we look at the vital organs, we have to understand that the hierarchy of life, organically speaking, how an organism, a multicellular organism, comes about in an organized way so that the organism as a whole functions in what we call life. All right, so we're going to look at vital organs and the hierarchy of cellular organization. And then we're going to look at some major causes of death in the United States. And then mostly in the second half of the lecture, we're going to look at this bioethical distinction between assisting or substituting vital organs. And that's going to be the key principle that really will govern the rest of the course, all right, with regards to bioethical issues at the end of life. The fundamental distinction between beginning or end of life, the fundamental distinction between assisting or substituting vital organs. Okay, so before we get right into the vital organ issue, let's look at what is known as the hierarchy of life, organically speaking, or the levels of biological organization. Essentially, there are 4 levels, and the basic level is the cell, right? What we call the cell, biologically speaking, organically speaking, we know that it is biological unit of life. Now, within the cell, there are a number of organelles that have particular functions, okay? Division of labor, just like in the body as a whole, we have organs that have different functions. Well, so does the cell. Within the cell, there are various structures, and these structures have different functions. For example, the most prominent organelle inside the cell typically is going to be what? Well, yeah, that's essential, of course. We can say it's a vital organelle. Most organelles in the cell are vital, keeping the cell alive. And there are several thousand mitochondria in each cell, but I was thinking more the most prominent one, structure and functionally, because it is like the center of organization, the one that coordinates all of the activity of the cell, albeit indirectly by sending messages out. And it's the nucleus, because the nucleus holds the DNA, which is the molecule of inheritance, and it's also the molecule of organization and the molecule of metabolism, because it is through the DNA that we have the genes, the coding for proteins. The proteins themselves will do the work. All right, so the nucleus is one of the organelles of the cell, the most prominent one typically, and typically there's one nucleus for a cell. And then all the other organelles develop outside of the nucleus in what is known as the cytoplasm of the cell, all right? So just like the individual has organs, the cell has organelles. But the cell as a whole is the basic unit of life. In other words, individual organelles are functioning within the cell, but if we just had mitochondria and chloroplasts and nuclei and lysosomes and ribosomes and all the different organelles laid out on top of the table, that cell is not functioning, okay? They have to be within the cell doing their particular function in particular regions of the cell. All right, so the cell then, a functioning, metabolizing cell, is the functional unit of life. Just like matter, for matter, what is the basic unit of matter, material things, that is stable? The atom, all right? So anything material can be broken down to its most fundamental basic unit, which is the atom. Now, the atom itself is composed of subatomic particles. But those individual subatomic particles, protons, neutrons, and electrons on their own are not stable. They're unstable. So they have to come together as a whole, as a complex whole that we call the atom. Okay, so similar by analogy, all the different organelles and membranes, including the cellular membrane in the cell, need to come together to form that functional unit. Then from there, we build up. We build up functionally, all right? So cells that have a similar function, they form tissues. Tissues that have a similar function form organs, and organs that have a similar function form systems. Those three passages, if you will, up to systems, it's all with similar functions, all right? So for example, we can look at blood cells. There are mostly three types of blood cells, three groups of blood cells. What do we have? We have the red blood cells, RBCs, that transport gases, right? Transport oxygen from the lungs to the tissues and transport CO2 from the tissues to the lung. Then we have white blood cells, WBCs, that are of different types, phagocytes and killer cells and neutrophils and so forth, but most of them are involved in precisely
immune response.
The immune response, exactly, to ward off foreign objects or agents within the body. What would be a foreign agent inside the body?
A pathogen.
Pathogens, virus,
Bacteria.
And fungal spores also, or actually objects like a pin or something like that, a pinprick. At any rate, those are white blood cells. And then there are others that are involved in healing, in producing the scab, and the
platelets.
The platelets, exactly. So those are the three main groups of cells in the blood. And then there's a liquid fraction of the blood, which is called plasma, right? And that has a number of nutrients and proteins and so forth. Together, we can see that the red blood cells, for example, are a tissue because they're cells with similar function. White blood cells are also a tissue and so forth. When we bring those tissues together, we have the organ of the blood. So the blood is the only liquid organ on the body, but it's considered an organ, okay? And then when we put the veins and arteries and heart together with the blood, then we go to the next level, which is the circulatory system. You follow? So again, cells with similar functions form tissues, tissues with similar functions form organs, organs with similar functions form systems. Then we have systems with different functions coming together. They form the organism as a whole. So, for example, we can talk about a dozen organ systems approximately, right? We can talk about a dozen organ systems, from half a dozen to a dozen, depending on how they're classified, if they're classified structurally or functionally. So for example, we could talk about the skeletal system, which are the bones in the body and the cartilage, right? Then we could talk about the muscular system, three types of muscles. We have the skeletal muscle, of which we have voluntary control. Skeletal muscles are attached to the skeleton, to bones. Then we have the smooth muscle that are unattached to bone, which are, for example, the digestive system is made up of smooth muscle, many internal organs, the reproductive system is made up of smooth muscle. Then there's a third type of muscle that is only one organ and has a self-beating pulse. In addition to being wired up to nerves, that is the heart, the cardiac muscle, right? So we got skeletal muscle, smooth muscle, and cardiac muscle. Those would be the different tissues that form the organs and the systems of the muscle system, the muscular system. That would be structurally. But if we put them together functionally, we talk about the skeletal muscular system as one. So depending on how they're classified, from half a dozen to a full dozen organ systems, what is another system, organ system of the body? We got the skeletal system, the muscular system, the respiratory system. Just basic review.
Nervous.
Nervous, circulatory, or respiratory, I mentioned, digestive system, the immune system, okay? The lymphatic system is another one that's kind of parallel to the circulatory system that carries lymph, in other words, nutrients through the body, okay? Reproductive system. And so you notice that at the system level, each system has a different function, but all of them coming together, then they form the organism. And again, they need to be coordinated, because if we laid out here on top of the desks a full intact circulatory system and an intact muscular system and skeletal system and so forth, the full dozen systems of the body, I laid them out individually, do we have a functioning organism? Absolutely not, right? They have to come together and function in coordination. And what is the system that coordinates all of the other systems? The nervous system, which is divided mostly in two main parts: the central nervous system, over which we have control, which includes the brain, the spinal cord, and then all of the nerves, the motor nerves that coordinate and innervate our muscles, our skeletal muscles, and that's why we can move voluntarily our skeleton. And then the involuntary nervous system, the peripheral nervous system, over which we don't have control. It works on automatic, and that's a good thing, because at night I don't have to tell my heart, 60 to 80 times a minute, beat, 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 or my lungs about 20 times a minute, breathe, 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 right? It happens involuntarily. And that, by the way, is controlled by what part of the brain? It's at the lower part, connecting into the spinal cord, and it's known as the brain stem, okay? The brain stem. Or the medulla oblongata in Latin. We'll get to it. Okay, so the point here is that all of the systems are coordinated by the nervous system, which is the innermost system of the body, anatomically speaking. And then the ones that, the other system that literally keeps us together as a bag, all right, and gives us integrity is the skin, which is also known as the integumentary system, okay? So I've given you a little handout. This is filled out, which has the different systems of the body, okay? Then, now I think we're ready to talk about vital organs after we have looked at this hierarchy of organization. So you notice that really life is layers of organization. It all begins with the cell, and within the cell, how do we know that a cell is alive versus another cell that is not alive, meaning that it is decaying? Because there is organization in the one cell and disorganization in the other. And the one that is keeping that organization is what we call metabolism. Again, at the organic level, metabolism, that the chemical reactions are occurring in a controlled way and in a coordinated fashion, so that typically there are cascades of chemical reactions which are extremely complex. You can imagine thousands and thousands of chemical reactions that are occurring in our cells, and they are all geared toward that particular organ, so that the liver cells do liver things and the nerve cells do nerve things and so on and so forth. And it's about the specific metabolism of each one of those systems, right? And that's what we call life. All right, so now we can look at vital organs. And just anatomically, we go from the head down. It's basically the head and the trunk of the body, right? Thorax and then abdomen. In the head, we have two vital organs, the brain and the brain stem, again, also known as the medulla oblongata, which is over here, not this part, this is the cerebellum, okay? Involved mostly in balance and other functions. But the brain, also known as the cerebrum, the two hemispheres of the brain, which is the different lobes and activity that goes on, mostly on the cortex, voluntary thinking process, and then the brain stem, which is here. Okay, and the brain stem is the one that controls and coordinates these involuntary functions of the body. It's not just circulation and respiration, it is also digestion, for example, and it is also the cycling of the reproductive system, many functions that occur within our body normally, naturally, and involuntarily. That is all regulated by the medulla. So the medulla is also a vital organ that is distinct from the brain. This distinction between the brain and the brain stem will become very important bioethically when we talk about a PVS, persistent vegetative state, or permanent vegetative state, what is known as a prolonged coma, or a person who is in a vegetative state, all right? Okay, so then going down into the core of the body at the level of the thorax, of course, the heart and the lungs, both lungs, because a person can live basically with one lung and keep on living. Like, for example, our Holy Father, Pope Francis, has only one lung. I don't know if it's the left or the right, but he had an accident, I think, when he was a child playing football, playing soccer, I believe, and lost one lung. Actually, we have 5 lungs, or 5 lobes, right? We have 3 lobes on one side and 2 lobes on the other side. And people can live with as little as 2 lobes of the lung. They're not going to run the marathon, of course. They're going to live a sedentary life, but they can live quiet, sedentary life with at least 2 lobes of the 5 lobes of the lung. And that's why I put functionally both lungs for vital organ. The heart, the liver has 3 lobes, and the lobes of the liver do regenerate. If I understand, one can donate 1 lobe of the liver and keep on living, and that lobe will regenerate, in contrast with the lobes of the lungs that do not regenerate. Then the pancreas is probably the smallest vital organ of the body, but vital because mostly because of the functioning. What does the pancreas produce? Insulin that regulates what? The amount of sugar in the blood, glucose specifically, right? And so very important, because too little sugar in the blood, we become anemic. Remember, sugar is the equivalent of gasoline for the body. It is a high energy molecule. Those carbon-to-carbon bonds, those covalent bonds, hold the energy. And too much sugar in the blood actually will lead to systemic organ failure. The organs will start dying with too much sugar, okay? So it's like a poison. Too much or too little will kill us. And the one that regulates that is the pancreas by secreting just the right amount of insulin, and therefore the diabetes and so forth. Okay, also the digestive system as a whole, we have the stomach, the small and large intestine. Another little clarification here of the small and large intestine is counterintuitive because the small intestine is longer than the large intestine, but thinner, and that's why it's called small. It's small in diameter, but longer in length. It's over 20 feet. I think it's about 24 feet of tubing that we have of the small intestine inside our abdominal region, okay? So it's longer, much longer than the large intestine. The large intestine, I don't know, I'm guessing it's gonna be about 4 to 6 feet, something like that, but much thinner in diameter, the small intestine, and that's why it's called small, but much longer, okay? Whereas the large intestine, as you can see here, is much larger in diameter, but shorter in length. There's a little appendix, which is obviously not a vital organ. Rather, it's considered a vestigial organ. I should have pointed that out. It's not a vital organ. The appendix is vestigial, meaning that is considered a remnant organ that has degenerated originally, probably when our ancestors had a much higher diet of fiber, of vegetable fiber. They may have been total herbivores or mostly herbivores. And so we had several segments of the stomach and the intestines, like the cattle have an extra segment of the stomach. They're called ruminants because they ruminate. To ruminate is to chew for a prolonged time, right? They chew the cod, they chew the grasses that they feed on, because we don't really digest cellulose, but we need to break it down to the smallest fractions possible. And then bacteria within our gut will digest some of the cellulose and break it down to smaller carbohydrates that can be then absorbed by the intestines, okay? And it's interesting how a vestigial organ like the appendix, which was thought to be that comes from another section of the intestines from some ancestor, right? Just like I was mentioning in the embryonic development early on, we have gill slits, which are reminiscent of openings to the gills, but we don't have actual gills, right? And then those gill slits in mammals become different parts of the jaw and different bones of the hearing. In fish, they become actual openings to the gills. The appendix similarly has developed a secondary function in some people, and it's associated with the immune system somehow. It's associated with the immune system. Other people are born without the appendix, and of course they have an advantage in that they can never get appendicitis, which can be life-threatening, right? Okay. So, but the appendix itself is not a vital organ. The large intestine as a whole is, and so is the small intestine and the stomach. Then we have the kidneys, again, both kidneys, because people can live with one kidney, no problem. As long as that one kidney is functioning normally, they can live with one kidney, right? And so later in the second fall, of the course, we'll look at organ transplantation and living and cadaveric organ transplantation. So this is mostly the vital organs of the body. To mention that there are many organs, other organs of the body that are also very important, but they're not vital in the literal sense of the word, in that we can live without them. For example, we can live without one eye, we can live without both eyes, we can live without hearing, we can live without the entire reproductive system. And so the reproductive system, as important as it is for men and women, is not a vital system, okay? Not for the individual. It's vital as a whole in the general population for the next generation. But then at that level, we go to the population as a whole. And as long as some people in the population are reproducing, as long as some individuals are reproducing, then that maintains the species, all right? But from the individual, they're not really vital organs. So, but these others are. So when we talk about end-of-life issues, typically we focus on these vital organs. And you see what how this will become relevant in the second half of today's session when we talk about that distinction between assisting or substituting vital organs, okay? Again, as I go along, any questions or comments, feel free to do that. Okay, now, since we're looking at vital organs and within the context of end-of-life issues, might as well visit the first lecture up front, the major causes of death in the United States. There's a list from the vital statistics, which is one of the functions of the federal government. It is fed by state numbers. Vital statistics agencies of each state feed into the national pool of numbers. So, and it's under the Center for Disease Controls and Prevention in Bethesda, Maryland. The CDC has become very famous since last year for tracking the coronavirus, etc. Okay, so the heart is a major killer in the United States. It's a heart attack, the good old heart attack, and mostly in men. And the critical window is actually the 40s and the 50s. So heart attack is still the major killer in the United States, which is mostly induced by stress. So one of the disadvantages of being an industrialized nation is the stress to keep growing and growing and growing. And so we don't find that in developing countries, okay? So that's the downside of having all the well-being that surrounds us. It can kill us. And the second major killer in the United States is tumors as a whole, cancers. So malignant tumors, we're talking about cancers here. You can see that between these two, it makes up more than 50% of all the deaths in the United States, between heart attack and all different kinds of cancers. The third is vascular diseases, cerebrovascular, mostly stroke. And so you can see the primary organ here, I've listed the vital organ that's involved, okay? So stroke is the second major killer, but you see quite a bit of drop, less than 10%, less than 7%, okay? Then there's a cluster from 7 to 3%, if you will, with respiratory illnesses, mostly things like emphysema and other diseases of the lungs. Then accidents is number 5. And between these 5, the first 5, that's 2/3 of all deaths in the United States are caused by these first 5, all right? Then it drops down quite a bit. Diabetes is 3%. Pneumonia or influenza, the flu is almost 3%, Alzheimer's 2.5%, kidney problems, chronic kidney nephrosis and kidney disease, less than 2%. Septicemia, which is poisoning of the blood. What can poison the blood? Mostly pathogens, but also chemicals, but mostly pathogens when it gets into the blood. Septicemia, which can lead to septic shock, which is sudden drop of pressure, blood pressure without going back up, and death is imminent with septicemia. Then suicide, 1.3%. Then liver diseases, including cirrhosis, liver damage, a little over 1%. Hypertension, again, high blood pressure associated with stroke, but not necessarily. Less than 1%, Parkinson's and homicide, less than 1%. And then all others about 17, less than 17%. But the takeaway from here is that two major killers in the US, heart attack and cancer, which, by the way, number of cancers are being associated with a weak immune system, and a weak immune system has also been associated with stress. So indirectly, either directly causing heart attack or indirectly causing cancer. Stress is a major killer in the US and in the industrialized world in general, which means North America and Europe mostly. Then other spotted countries here and there. All right, let's move forward a little bit. Okay, at this point, this has been mostly biology and some clinical charts there. We can now look at this distinction between assisting or substituting vital organs, unless someone has any question here. I'll send you this filled in outline. But basically, we've been looking at the first page here. Now we're in the second half. So it's 10:15, it's a little early, but so if we take a break now, it probably won't take us until 12. We can take a little break now for about 15 minutes and then come back, and we'll probably finish within an hour or so. Okay, so why don't we do that? I'm going to pause, take a 15-minute break, and start up again at 10:30, all right? Time to thaw out a little bit. Okay, folks, welcome back. We're going to go into the second part now of this first lecture of bioethical issues at the end of human life. And we're going to look at one basic principle here, which is the distinction between assisting or substituting vital organs, okay? I also sent you a little write-up that I did a few years ago. Let's see if I find it. No, it's not that one. I thought I had downloaded it. Oh, yes. It looks like this. So you can take a look at that later, all right? But basically, I'm going to give you the summary. It's got its references. Okay, so basically this is what we're talking about here on the distinction between assisting or substituting vital organs. The punchline is that there is generally an obligation, an ethical obligation to assist vital organs, all right? To assist vital organs. But there is no bioethical obligation to substitute a vital organ. Now, it may sound a little hard at first, but when people are not clear about a basic principle, this is a technique that is attributed to Thomas Aquinas. Aquinas would say, look at the opposite and see if it makes sense. Imagine if there was an ethical obligation to substitute vital organs when they're failing irreversibly. For example, if the heart is failing, congestive heart failure, and it's irreversible, okay? if there was an obligation to substitute that vital organ, we'd have an obligation to do heart transplants, either from a cadaveric heart, right? Or a heart machine. But it's untenable. In other words, every organ, every vital organ is going to fail sooner or later. It's going to fail sooner or later. And imagine if we had an obligation, an ethical obligation to substitute vital organs, it cannot be done. It's impossible for medicine to do that. And so, no, there is no obligation to substitute vital organs. Rather, when a vital organ is dying irreversibly, that is indicating the death of the person, precisely because it's a vital organ. And all it takes is one vital organ to fail irreversibly for that person to die, right? Because that's why they're vital, by definition. So there is generally an obligation to assist vital organs, but not to substitute them. I want to look at some examples. We're going to look at 3 examples on the kidneys, on the lungs, and on the heart, precisely. So beginning with the kidney, we have dialysis. Now, the challenge here is that sometimes the medical terminology doesn't match up with the bioethical terminology. You'll see in dialysis, it's a clear example. Dialysis is when a person is on renal failure. It could be temporary or permanent chronic renal failure, right? The kidneys are not functioning up to par. They may not be functioning at all or functioning too little to keep the person alive. What is one of the major functions of the kidney, of the kidneys? They filter, yes, but what do they filter out of the blood? Yeah, the waste, the toxins, which is mostly breakdown of metabolism, all right? Catabolism is the breakdown, and it's mostly the breakdown of proteins into smaller components, ammonia, and it's toxic to the body. So nitrogen waste, all right, has to be eliminated. And though that nitrogen waste, mostly ammonia, has to be dissolved, those crystals are dissolved in water. So at the same time, the kidneys are osmoregulators. They regulate the amount of water in the blood, and therefore they also regulate the blood pressure. You see, because water, we're mostly water, right? We're between around 85, 90% water. And so by the kidneys pulling out water out of the blood, then they are adjusting the blood pressure on the circulatory system, okay? And they have to pull out water, the kidneys have to pull out water from the blood. Why? Because the waste is dissolved in the water. The ammonia and the other nitrogen waste are dissolved in the water fraction, the liquid fraction of the blood, precisely in the plasma, okay? So the kidneys necessarily have to pull out water from the blood, and then that is what is known as urine. It's sent from the kidneys through the little ureters to the bladder, and the bladder is a storage tank. And when that tank starts filling up, then we urinate through the urethra, which is a single tube out, all right? So that's the urinary system that regulates both, takes care of toxins in the blood, and at the same time is an osmoregulator, regulates the osmotic pressure, meaning the water pressure or the blood pressure of the circulatory system. Now, essentially then it's a filter, okay? Dialysis is essentially an artificial kidney. In other words, the blood is taken out of the individual, out of the patient, put through the machine, and those filters, which is literally here, the filter, okay, filter out the toxins from the blood and then pump the clean blood back into the individual. but they also have to add water, distilled water, right, from the water that was taken out with the toxins. And so the dialysis machine also osmoregulates the pressure, the blood pressure of the patient who is on dialysis. And that's why it also has a bag of saline solution, right, hooked up to the machine. And the technician will be checking the controls, making sure that the pressure is constant and so forth. And that's also why the patient, every time the patient goes on dialysis, the patient needs to sign what? A form, a release form for in case the patient goes into a heart attack because of the machine malfunctions and the osmoregulation is runs amok, and the patient can suffer a heart attack, all right? So there's always on call a nephrologist and other doctors are on call when these kidney centers are functioning, just in case a patient has some issue with the blood pressure, okay? So they have to sign a consent form every time they go on the machine. Anyway, these centers are throughout the city and throughout the whole United States. A person can be on dialysis. Typically, it's a fairly rigorous regimen. I don't know if you know of anyone who is or has been on dialysis. Typically, it's 1 day on, 1 day off. So they'll have two systems. They'll have Monday, Wednesday, Friday, or Tuesday, Thursday, Saturday. And then some days it's off. And it could be anywhere from 2 to 4 hours, more or less, on the machine, depending on body mass, right? They weigh the patient every time they come in first, and then they figure out how long they have to be on the machine to filter their blood and so forth. So it's pretty rigorous, and over time, it takes a toll on the patient. Typically, they spend the off day trying to recover from the on day. So if they were on Monday, then on Tuesday, they stay quiet and try to recover from the Monday treatment. And then Wednesday, they're back on the machine again. So it's pretty taxing. Again, depending on the age and how healthy the person is overall. Younger people who are healthy tolerate it better than older people. But it can be long-term. Some people can be on dialysis for years or decades. Typically, they're waiting for a transplant if they want to do that, right? Either living or cadaveric. And over a long period of time, if they're low on the transplant list and they are not candidates, maybe they've had 1 transplant already or 2 and are on renal failure again, because no transplant is going to last forever, right? No kidney transplant. Then comes the question, may they get off the machine or not? Or are they, hooked onto the machine for life until they literally die, either on the machine or on the off day? Well, what's your intuition with regards to dialysis, knowing now what the function of the dialysis machine is? Is it assisting the kidneys or substituting the kidneys? Well, some may say assisting, some may say substituting, but typically, if the patient is on chronic renal failure, chronic kidney failure, it means that they cannot live, that they're going to be intoxicated. Their kidneys are not functioning to 100%. They may be down to 10, 5% or 0%, right? But the kidneys are not functioning enough to filter out all of the toxins of the blood. But if they go on dialysis, they can live for years and decades. So really, the dialysis typically substitutes the kidneys. Okay, as sophisticated as it is, dialysis substitutes the kidneys. So the bottom line is that there's no bioethical obligation to go on dialysis. There's generally no obligation to go on dialysis. And this is a challenge because certainly for any clinician, for any nephrologist, and for any medical doctor, dialysis is standard care. Renal failure, dialysis, you know. If the diagnosis is renal failure, then the protocol is dialysis. So it's standard medical practice. And yet, it is an extraordinary means of life support. Okay? It's extraordinary means of life support because it substitutes the kidneys. And therefore, there's really no moral obligation, no bioethical obligation to go on dialysis. Now, I say generally because there may be some exceptions. For example, if the patient is a good candidate for receiving a kidney, especially if it's a target donation of a family member or a relative who is donating specifically to this patient, you know, but they need a few months or some time while all the protocols are done, either on the donor or on the patient himself or herself, then dialysis may be the indication, but it's temporary because they're getting a new kidney, right? And so that one could make a case there, but even the transplantation itself, is there an obligation to do organ transplants? No, because organ transplants, vital organ transplants, are substituting the deceased organ, right? The failing organ. So it's a substitution. There's no obligation ever to undergo a vital organ transplant. Okay? It may save the life of the person for sure, of the patient, but there's no moral obligation. The same here. With dialysis, there's no bioethical obligation to undergo dialysis, and yet it is standard medical practice. So it's a challenge. I say this because at some point over the years or the decades, some patients, especially elderly patients, may just get sick and tired of the dialysis. You know, the whole life eventually revolves about going to the dialysis center. And then, like I say, they spend the off days recovering from, because it's very draining. It leaves them very weak and tired. And so at some point they may refuse to go any longer to dialysis. And then what's going to happen is that they're going to intoxicate themselves basically and start dying, you know, go into systemic organ failure, beginning with the kidneys and so forth. We never abandon patients. And then what is going to kick in is comfort care, but there's no longer a cure, okay? So a patient in good conscience may at some point refuse dialysis, a patient on kidney failure, and then they're going to die from systemic shutdown of intoxication of the body. So that's an example where we have a machine or a protocol that is substituting a vital organ, and therefore there's no ethical obligation. But it is standard medical practice, meaning that it's not experimental. So it's challenging mostly for the doctor to accept that their patient has said, thank you, doctor, but no thank you. See you on the other side. All right. Okay, now let's look at the lungs. The typical machine for the lungs is the ventilator, but there is a minor assistance to the lungs, and that is typically for the respirator. The intuition here is kind of counterintuitive, at least for me, on the terminology. So respirator are cannulas to the nose or other gadgets to the nose that are supplying oxygen, enriched oxygen, but the lungs are doing the breathing on their own, okay? So these various respirators are assisting the lungs, they're not substituting the lungs. Different for the ventilator, that is an intubation, all right? So it's a tube to the lungs that may either assist or substitute the lungs depending on the settings. So let's look at these first. Here are 3 types of respirators, and which, by the way, the medical profession is a little ambiguous here, in my opinion, because sometimes this terminology is not that distinct, like I'm making it for doctors, clinicians, and even pulmonologists. They'll use ventilator and respirator interchangeably. However, from the bioethical perspective, this one, it only assists the lungs. The cannula, you've seen this in patients, I'm sure. They just provide, there are two little tubes that go into the nostrils, and this is connected to either an oxygen tank that is portable and can be at home, for example, people with emphysema or some other debilitating lung condition, or in the hospital directly there's a little tube that supplies oxygen from the wall internally. So there are internal tubes in the structure of the building that actually supply the oxygen so that they don't have to carry around cylinders inside the rooms, okay? But that tube is connected then to this, typically it's known as a cannula, or this is a mask. It's a loose mask because now it includes nose and mouth, but there is some leeway around the mask. Is loosely fit around the face, not tight. And now this one, you can see it's more aggressive, if you will. This is typically known as a CPAP, and it is strapped onto the face of the patient, including nose and mouth, but it is sealed around the face, around the nose and mouth, and so that the oxygen is forced into the nose and mouth, but the lungs are still breathing on their own. So this is the maximum kind of assistance to the lungs with pure oxygen, and the cannula would be the minimal, obviously, because the person can still breathe also through the nostrils, the atmospheric air, and also through the mouth, okay? So these I'm calling strictly ventilators, functionally in the sense that they're only assisting the breathing function. The ventilator, or the vent, is a little different. This is an actual tube that is inserted into the trachea down to the base of the lungs, all right, where the bronchi branch out. And so the ventilator is hooked up to a machine, and it's kind of a double machine. At the center here, it actually has a bellows or a diaphragm that goes up and down, a piston, that is forcing the air, the oxygen, directly into the lungs. And by that bellowing action of going up and down, that piston is actually forcing the lungs to breathe, all right? It causes positive pressure on the alveoli so that the alveoli have to take in the air or the oxygen that is surrounding them, pushed in by the apparatus, by the machine. Has this other little tubes that humidify the oxygen and so forth. And then the settings are determined by the technician. Okay. And so what they measure is what is known as perfusion, which is on the finger, right? It's a little device that is put on the finger. And this little perfusion device, which you can also buy apparently and hook it up to the phone, the cell phone. That's the one I'm looking for, okay? Let's see, let's look at some images here. Yeah, this little gadgets that are put on the finger, they actually measure the amount of oxygen. I think it's done electronically somehow. But they measure the amount of oxygen, this little clip, right? In the blood, they measure the oxygen in the blood. And the good perfusion is above 95%, like 97, 98, 99%. If the perfusion goes, as you can see here, the reading, okay, 98, 98, 99. If the perfusion goes below 95% saturation, 95% saturation on the blood, the alarms go off and all the nurses and doctors get worried and crazy, and they come into the unit and see what's going on with the machine. because there's too little perfusion, okay? So that's what they check for. Oh, here it is. It's right on the finger, the little clip that measures oxygen saturation in the blood. And typically it's above 95%. But what they do is when a person is intubated, when a patient is intubated, typically they start the machine at 100%, pushing oxygen into the lungs. And then right away they start a weaning process, So it's a very active dynamic system whereby the technician will start lowering the percentage of oxygen that is being pushed into the lungs. And in the hope that the lungs will start taking up the slack, all right? So they'll go down maybe to 95%. I'm not talking about perfusion now, I'm talking about the percentage of oxygen that is being pushed into the lungs, all right? Hoping that the lungs will now start picking up 5% of the action on their own. Then if, and they'll leave it there for several hours or minutes, depending on the protocol. And then maybe a couple hours later or 1 hour later, the technician will come back, and if the patient has tolerated that, that weaning process, all right, they may go down to 90%, hoping that the lungs will pick up 10%. And then if the patient responds, if the lungs respond, they'll take it up to 85% and so forth. So you see, they start a weaning process right away as soon as the patient is hooked up. It would take several hours to several days. And by the time they're down to 60% or so on the machine and the lungs are doing 40 to 50% breathing, that may now indicate extubation, all right, extubation. And what they do is typically the pulmonologist will come up to the patient. Oh, sorry, in the meantime, the patient is also induced in a coma. It's an induced coma. All right, meaning that the patient normally would be awake, but because they have this tube through their throat into the lung, it's an extremely uncomfortable thing. And some patients, especially the elderly, they'll try to yank it out. And so they induce a coma on the person. It's a temporary coma. And there will be also, there will be a somnifer. In other words, they will put the person to sleep, literally, not figuratively, like euthanizing the person, okay, but they just put him to sleep, a somnifer. And also they will give a muscle relaxant, right? So that the patient does relax, at least on the skeletal muscles and so forth. So the person is asleep or in a coma, and then they'll start, when they're getting ready to extubate, they'll start diminishing the somnifer, the sedative, and typically the pulmonologist will come up to the patient's ear and start saying in a loud voice repeatedly, "Don't swallow, don't swallow, don't swallow, don't swallow." They'll take the tube out. And then it's the moment of truth. Either the patient breathes on their own and they go and breathe, or they start gasping, and then depending whether there's an order, a DNR order or not, do not resuscitate or not, the patient will either be re-intubated or giving sedatives and allowed to die because there was a do not resuscitate order, okay? So those are the two alternatives there upon extubation. You have to go patient by patient. It depends on the condition. It depends on the prognosis and on the diagnosis and the prognosis, right? The hope of recovery. But one typical scenario where the vent is assisting the patient could be, for example, a patient with pneumonia. What do they need? They need antibiotics, and they need 1 to 2 weeks for the antibiotics to kick in, do their function, and kill the pneumococcus, right? And therefore, they can be intubated, fully intubated, starting with 100% and slowly the weaning process, but they'll wait until the antibiotics start to function, and they'll be taking blood samples on a regular basis to see if the pneumonia is subsiding, all right? And then typically in 2-3 weeks maximum, that the vent can be maintained through the trachea, all right? Through the mouth into the lungs. And then if the antibiotics have worked and the patient has recovered from pneumonia, then they'll extubate. The patient will then recover full health, hopefully. A different case would be with, for example, a vegetative state when they're having difficulty breathing, or they have emphysema or some other chronic condition where they have to be on the vent more than 3 weeks. Then the critical decision comes because the tube cannot be maintained for more than typically 2 weeks through the mouth. What happens is it irritates the vocal cords, and also there's a greater chance of infection, right? And now the critical decision comes if the patient has given orders prior, or the family or the next of kin or the proxy determines that the patient should continue intubation. They have to do a tracheotomy, a hole underneath the vocal cords at the base of the neck here, and then extubate and re-intubate through the trachea, right? Through the trachea. And when they do that, then that tube can be maintained essentially indefinitely. And the patient can be maintained in a coma or in a vegetative state with the ventilator for years and decades, okay? And so this decision to extubate through the mouth and re-intubate through the trachea through a tracheostomy. The tracheostomy is the hole, and the tracheotomy is the procedure. It's a critical bioethical decision, because that means that this patient can now be maintained there, but for years and maybe even decades. But would the patient want that? Okay, would the patient want that? Because at that point, the machine definitely now has gone from assisting the patient to substituting the lungs, all right, to substituting the lungs. So long-term, especially with the tracheotomy, a ventilator at that point is substituting the lungs, because the lungs have become lazy or diseased and will no longer breathe on their own. So the machine, the vent, is respiring, is breathing for the patient, all right? Is pumping in oxygen and then exhaling CO2 and discarding the CO2 and pumping oxygen back in and so forth. So at this point, the vent has substituted the lungs, and over some time, the decision may be now the patient will continue in a persistent vegetative state or an induced coma indefinitely. And at that point, the next of kin or the proxy may make the decision to extubate and allow the patient to die, all right? And it will be the critical distinction between killing or allowing to die. Difficult decision, because nobody wants to disconnect grandpa or grandma, all right? But by disconnecting, pulling the plug, as they say, doesn't mean necessarily that we are killing that patient. We may actually be allowing that patient to die in peace, because the vital organ of the lungs has already died, all right? So again, bottom line for the vent, it depends on the settings. It could be assisting at first temporarily, but long-term, the vent will substitute the lungs, and therefore there's no bioethical obligation to maintain that patient indefinitely on the vent. All right, the third example. By the way, people can live with a tracheotomy if the patient does recover and the vent can be disconnected, all right? And people can live with a tracheotomy and they'll breathe through there. Typically, they cannot breathe, they cannot speak any longer because the vocal cords are damaged. Sometimes they can use a little machine that is put here and translates the vibrations into sound, right? But typically the vocal cords are shot, but they can breathe through there. They just have to be careful not to get any foreign object because it's going to go right into the lungs and they're going to get a pneumonia, an infection, okay? And so they can wear a scarf or some other device that is a filtering mechanism, okay? But people with a tracheotomy can still live if they recover from whatever condition they had of the lungs. Okay, the third example is the heart. And when the heart fails, then the protocol is a cardiopulmonary resuscitation, also known as CPR. And again, CPR may either assist or substitute the heart depending on the clinical condition of the patient. Generally, if the patient is young and is otherwise healthy, then CPR is indicated and that patient should be revived, the heart restarted by the compressions and the CPR technique, all right? But if the patient is elderly, the challenge with CPR is that on an elderly patient, typically we lose calcium as we age, and it makes our bones more brittle, and even more so on women, they tend to lose more calcium, osteoporosis sets in. And what happens with the compressions, since they are fairly vigorous, on an elderly person, compressions on the chest may actually break the ribs or the sternum, and those broken ribs can puncture a lung. And so now the situation is worse because after the heart attack, now this patient has a perforated lung and broken ribs to deal with, and there is no fast cure for broken ribs. They just have to be left alone with difficulty breathing and pain at every breath, and the possibility of clots and blood seeping through the wound and so forth. So for elderly people having heart attack, CPR may be contraindicated, okay? And so it really does depend patient to patient. Generally on young patients with a heart attack because of stress, they can be saved with CPR, but on the elderly, perhaps it is better to let the person die in peace. Why? Because the heart has stopped naturally, and that's a vital organ. Okay, and if the heart has stopped naturally, then that indicates the death of that vital organ and therefore the death of that person. It's challenging because, for example, for when one calls 911 and the rescue team comes, the paramedics, typically by law, they need to resuscitate. So if there's not a do not resuscitate order, a DNR order on that elderly patient, they will resuscitate the patient, you know, and it's a challenge for them. I understand that they're kind of exonerated from lawsuits, but it's a challenge when 911, when rescue is called for an elderly person, because they typically have to resuscitate that person, but it may be contraindicated, okay? So for the elderly, it's a conversation to have when that elderly person, it could be our grandparents, it could be older family members, are still somewhat lucid and sane in their mind to understand that if vital organs are collapsing and vital organs are stopping, are no longer functioning, that's indicating the death of a person. May be somewhat subtle, like kidney failure, or maybe more dramatic, like heart failure, all right? But it's a conversation to have with the elderly to ask, do you want to be resuscitated? Do you want to risk perforated lung and broken ribs? Or do you want to be allowed to let go and to die in peace? Challenging to see a person go through a heart attack and not resuscitate them. but it is the death of a vital organ. Okay, so this is the kind of conversation that we want to have with our elderly family members while they can still process the consequences of being resuscitated. All right. So again, CPR may either assist or substitute the heart, depending on the patient. Also, with the defibrillators, the different kinds of defibrillators that are available, including one right across the door here, the opposite wall of the hallway. These typically put a current through the heart. They zap the heart, and the patient tends to jump at that moment, is to reestablish the electrical. So this is done for a different reason, but to restart the electrical activity of the heart that is normally supplied by the nerves, and to get it started again. Again, defibrillators, depending on each patient, may assist or substitute the heart, and therefore it may be a decision to use the defibrillator or to forego and to let it go. Okay. So that's why at the end of life, we basically have to go patient by patient and decide on the moment, critically, whether the protocol that is indicated for reviving this person is assisting or substituting the vital organ that is failing, or it could be several organs that are failing simultaneously. And those are critical decisions. And that's why it's important to have these conversations ahead of time with elderly family members, because if we don't have the conversation, then we'll have to make the decision, especially if we become proxy or next of kin, to decide on their behalf. And who knows what they would have desired. Even though realistically, I mean, a lot of it is common sense, because even if there are no DNR orders, okay, I think this is a type of situation where we need to be thinking actively and ask the question, would I want to live in a state like this for years or decades or not? And most people will say, I would not like to live like this, because what's the point, all right? And it's not utilitarian. I mean, we're not focusing entirely just on quality of life. We say, well, this patient has no quality of life because they can't get up, they cannot read the newspaper, they cannot walk around the park, they cannot enjoy their grandchildren, right? They can't even enjoy a good meal. And so the quality of life is gone. Well, we have to be careful with that argument. Rather, our argument would be, we're only here for a time. We're not meant to be here on earth forever. Okay, and rather, this is a relatively short time when we put it in the perspective of eternal life, which is really our ultimate destiny as believers. And even as non-believers, even non-believers cannot avoid eternal life one way or another, because it's a universal process, okay? And therefore, if a vital organ has failed irreversibly, I, in conscience, can make the decision, let me go. Just give me the palliative care to minimize my suffering or my pain and so forth, and rather switch on the spiritual aspect of what I need at the end of life, which for us, for baptized, for example, would be the last rites, the anointing of the sick, and so forth, okay? And the spiritual dimension, which we'll get into in future lectures, but basically I want to set the kind of the groundwork now by looking at vital organs and a number of protocols that either assist or substitute vital organs when they're failing. And the typical question, is this organ failing irreversibly? Okay, so that's a question that we can ask the clinician, the doctor, because the doctor will not understand. I can tell you the doctor typically will not understand, well, doctor, is this protocol assisting or substituting the vital organ in question? They do not think in those terms. That's not medical terminology in medical school, all right? And so we have to translate that into something clinical that they understand. Like, for example, has this organ begun to fail irreversibly? they'll understand that language, okay? Irreversible or chronic heart failure, chronic kidney failure, chronic liver failure, chronic lung failure, they understand that terminology. We translate it into assisting or substituting. And then we can make that bridge into the bioethical decision, no obligation to assist vital organs, no obligation to substitute vital organs, but yes, to assist them, right? Okay, so that's the bottom line there. Then as we go through the course, we'll be looking at what is extraordinary and or ordinary means of life support. So that's going to dovetail in with this language, but that's very ethical or moral language. That's bioethical language. Ordinary or extraordinary means of life support is, again, not necessarily what the doctors are familiar with, the clinicians, so we have to translate that into clinical terms. And then we're going to be looking also at the distinction between cure and care, and what obligates there bioethically between cure and care. We're also going to be looking at the definition of death and the uniform declaration of death, which happened in the 1980s for the whole United States and so forth. And finally, we're going to be looking at nutrition and hydration. When does it obligate, when not? Because in principle, nutrition and hydration are normal body functions, so they obligate, in principle, they obligate. They're part of assisting vital organs, keeping a person alive, nutrition and hydration, okay, together with two other aspects of assistance or normal care for an individual. And then finally, we're going to look at physician-assisted suicide and euthanasia, which is becoming increasingly legal in a number of states. About 1/10 of the states of the United States have already legalized physician-assisted suicide. So something very, very to be concerned about in the United States and in the developed world as a whole. Okay, that's it, unless someone has any question or comments. So we'll go forward. I'll include the...
I have a question.
Yes, sure. Who is this? Jorge? Or Christopher?
George. See.
Okay.
Oh, sorry.
George.
Yes, go ahead, George.
So my question, what? You once mentioned that there was a difference between pain and suffering when it came to animals. We're going to talk about that in this course?
Yes, I'll be covering a little more fully, but since we have plenty of time, this is kind of a short lecture, this first one. Pain and suffering, think about this. They're not necessarily the same. Pain is more at the physiological level, at the physical level. Suffering is more at the psychological level. And again, in the medical profession, in my experience, clinicians will use pain and suffering kind of interchangeably. But I tend to give a kind of a graphic example. Let's say you have a couple and they're having their first child or any child, but they're having a baby, and literally she's having the baby. So she's in labor pains, right? She's in pain, but not necessarily suffering, because let's say it's their first baby, right? And they've been looking for this baby for quite a while, and finally they're having their baby. So she's in pain, but she's not necessarily suffering. But he is watching her going into labor and screaming and yelling and kicking and panting. And so he is suffering, but he doesn't have one bit of pain. The husband is not in pain, but he is suffering because she's in pain. So that's kind of a graphic example of the distinction between pain and suffering. Now, typically they come together, and I can tell you, with the root canal that I just had, and I try to stay away from the painkillers, I was in pain and I was a little bit suffering, both together. But sometimes they don't necessarily go together, okay? Pain is more at the physical level, physiological level. Suffering is more at the psychological level. And some people are just scared of pain, all right? And so some people have a lot of tolerance for pain, but they don't go together necessarily. They can be distinguished because I understand that pain is more at the physical level of nerve hitting our pain centers of the brain, but suffering is what we do with the pain, all right, or with the pain of others. And we can suffer vicariously by seeing others being in pain or in suffering and not experience the actual pain ourselves. But I can tell you that clinicians many times use the terms interchangeably, and they'll talk about putting people out of their pain or putting people out of their suffering, right? On animals, that's a challenge when we look at animals, and in part, that's perhaps how we can justify euthanizing an animal and not euthanizing a human being, right? When a dog, for example, a pet, is in a lot of pain, we don't really know if they're suffering or not. We don't, okay? We don't know if they're suffering or not, but they're in pain. They're screaming and yelling and so forth because either an accident or they have developed cancer or some other, or they're old and senile, like what happened to Dolly that started developing arthritis and other illnesses of the elderly. So they thought that she was at least in pain, if not suffering, and then they put her to sleep, literally, I mean, not sleeping, but actually they euthanized her. They put her to death, right? So we can euthanize animals, but we should not euthanize humans. Okay, we'll get more into this as we go along, but we also we're going to look at next class at the different levels of unconsciousness, all right? So we're conscious now, more or less through the day, but then there are different types of unconsciousness that we need to deal with, particularly the PVS, persistent or permanent vegetative state, because that can go on for years or decades, all right? But then we can ask, does the patient want to continue this way or not? And the PVS that is most challenging is the one that doesn't need a vent. The person is breathing on their own. They just need nutrition and hydration, like the case of Terry Schiavo. How many of you remember the case of Terry Schiavo? Yeah, okay. Terry Schiavo was very famous here in Miami, in Florida, a couple of decades ago in the 1990s, and we'll look at her case because it was a big to-do, very dramatic. For years, she was in a vegetative state, whether to disconnect her peg, her tube to the stomach or not, okay? We'll look at that case in some detail when we get at nutrition and hydration. Okay, so this is all I have for now. If there are any other questions, happy to address them. Otherwise, we can close here for now and pick it up next Saturday. We'll look at mostly at the different levels of consciousness, clinically and bioethically. Okay, people are good. So let me close down.
Thank you.
Okay,
Professor.
welcome.
Have a good one, guys.
We'll have a